Hello.
Hello, good morning, sir.
Hi, good morning, Ishan. How are you doing?
I'm doing great, sir. So we're actually waiting for more attendees to join. We'll be
No
beginning.
worries. We'll take a couple of minutes time. That's fine. I just wanted to check in the meantime if I'm able to share my screen and everything is working fine.
Sure,
Sure,
sir.
sir. Good morning, sir. I'm Tanmay.
Hi, Tanmay. How are you doing?
Yes, sir. So we'll be starting at in 5 to 10 minutes, and we are waiting for yes. So we you can test your.
Awesome. Okay, you're seeing only the slides here, right?
Yes, sir.
Okay, awesome. Hmm. Video is working. Just a second. Okay, awesome. Everything is working. And my camera too.
Hello everyone, we would be starting in a minute. Good morning and welcome to all. We, on behalf of the Technology Robotics Society, IIT Kharagpur, in association with IEEE Kharagpur Student Branch, feel immensely honored to welcome Dr. Anush Sankaran as our first speaker in our guest lecture series as part of the Winter School for AI and Robotics. Welcome, sir.
Dr. Anush Sankaran is a senior research scientist at Microsoft. He is a former senior research scientist at IBM Research AI. He received his doctorate in computer science from IIIT Delhi and currently works in the areas of deep learning and computer vision. His research expertise is in the applications of machine learning and deep learning with applications to computer vision and natural language processing. He has worked on a variety of applied research projects and specializes in the introduction of machine learning and deep learning based solutions to traditional industry problems.
Today, he will be speaking about the democratization of deep learning. I now request sir to kindly take over.
So, can you please unmute your mic? It is muted.
Am I audible now?
Yes, sir. Please
Wonderful.
continue.
Ishan and Parth, thank you so much for that wonderful introduction. I almost forgot half the things that you mentioned there. It's good to remember and recollect those things. And thank you each and every one of you for coming to this presentation on a Saturday morning. I know it's Saturday and it's a weekend. You could be sleeping in your dorms or just watching a movie. Instead, you choose to come here. So I'll try to keep this presentation as interactive as possible and as much close as possible to a movie. I just want to let you know that it's going to be a fun presentation, nothing very serious. So at any point of time, if you should have some questions or comments, or if you want to discuss upon a particular slide, feel free to just unmute yourself and have a conversation with me, or you can raise your hands in Teams, or you can just add a chat note in the comments. I will keep an eye on all of them. Okay, having said that, let me start with some facts and see if you're aware of these facts or not. Um, did you know that in 2021 alone, there were more than 1,400 self-driving cars on the roads in US? There's a good chance that if you book a cab or if you walk on the road, one of the cars that you see, especially in the west coast of US, is a self-driving autonomous vehicle that doesn't have a driver in it. Did you also know that detecting brain tumors, one of the toughest medical science problems, automated systems can do it more accurate than human doctors. And the best part is they can do it much, much faster in about less than 150 seconds. Like all it takes is 2.5 minutes for a machine to detect if you have brain cancer or not. And they can do it more accurately than a human doctor specialist as well. Did you also know that AI systems are not only intelligent, but they are very creative as well, in the sense that they can compose music, they can write poems and stories, they can create new fashion, clothings, as well as they can draw paintings. It would not be an exaggeration if I tell that the last decade, specifically the last decade of 2010 to 2020, has produced a complete revolution in terms of AI and automation. Now, there were so many revolutionary ideas and applications that were brought forth into practical world in the last decade or so. You would be wondering, wow, there were so many advancements that were made in AI and automation. But can you actually believe it? All of this is possible because of one tiny small advancement that was made in the last decade, and that is what we call as deep learning. The people introduced deep learning. Deep learning has been there for quite some time, but people were not able to crack its fundamental problem. But roughly around the period of 2010, people cracked on how we can practically use deep learning in our real world applications. And that deep learning has led to a lot of applications in almost every industry. You saw a lot of examples, like creative industries, fashion industry, music industry, healthcare, medical industry, autonomous vehicle industry. So there were lots of industries that were positively influenced and revolutionized by deep learning. Now, having said that, you will be under the impression that I'm going to teach you or tell you what deep learning is in this particular presentation. Unfortunately, no, because deep learning is such a vast and huge subject, and I won't be doing justice to it if I'm going to teach you in like less than 45 minutes. Instead, let me give you a interesting flavor of how we can use deep learning in our projects, in our lives. If I want to build an interesting app or an application, how can I just use deep learning? So most of these things that I'm going to present in the next 30, 40 minutes is accumulation of my last 10 years of research that I've been personally doing. I'm most passionate about these problems. So if you have any questions, I'll be very happy to discuss. Let's take an example. Here is an exact example of a deep learning model that I am showing here. It's actually two different models. The one model on the top, there's a different model on the bottom. In very simple terms, a deep learning model is a sophisticated neural network. And people, if you don't know neural network, don't worry about it. It's just a it's just a machine. It's just a design. It's a mathematical function at the end of the day. And a deep learning model would look something like this. Okay. And this is what helps us in solving some of the problems that I mentioned till now. Okay. Um, the first question as programmers, as computer science engineers, or even engineers that comes to your mind is, if I have such a deep learning model, can I implement it? Can I use it? Yes. So there are multiple programming libraries and languages that are present to help you implement a deep learning model. I'll give you some examples. There is a library called Cafe. You'll have to approximately write 2000 lines of code to implement the specific model that I showed in the previous slide. There is a different library called TensorFlow or Keras. It is by Google. And if you need to implement the same model in this library, it will take you approximately 700 lines of codes. And there is a different library called PyTorch that is currently being developed by Facebook. And if you want to implement the same deep learning model using PyTorch, you'll have to write 600 lines of code. And these codes are pretty much obfuscated, a bit complex, and it takes a lot of time to write these codes. Um, just give me a show of hands. How many of you feel as soon as I show a deep learning model and its corresponding code to you, how many of you feel like this? Nobody? Yeah. And trust me, when I was introduced to deep learning in the first place, I felt like this too, that it didn't make any sense to me. It was pretty difficult to learn. It was pretty difficult to use, implement, and all those stuff. So deep learning, apart from its algorithmic challenges, like how do I improve the accuracy of a particular application? How do I improve the accuracy of brain tumor detection? How do I make it better? Apart from those kinds of fundamental questions, there are lots of other questions in deep learning as well. That can I use deep learning? That's the first question. Can I use? How difficult is it for me to use deep learning in the applications that I'm building, in the mini projects that I'm doing, in the course projects that I'm doing? Well, there are lots of challenges. The first challenge is it's learning. Deep learning is a high learning curve. It takes time, skills, and efforts. before you can sort of implement your first deep learning model. And it typically takes people a couple of years before they can call themselves AI can implement deep learning models, right? So if you want to start using it, you'll have to learn deep learning for a couple of years, first of all. And after that, I showed you in the previous slide, right? There are different libraries that different companies are using. Like Google is using a different library, Facebook is using a different library, Microsoft is using a different library. So if I implement a deep learning model in one library or language, I cannot use that deep learning model to communicate with other libraries or languages. To oversimplify this problem to you, it is as simple as, hey, if I have a part of my program in C, a different part of my program in Java, a different part of my program in Python, how can I combine all of these to make a single system? Right now, we have some solutions for those kinds of basic programming problems, like how do we communicate between C, Java, Python, etc. But using that in deep learning is not yet a solved problem. So it's very difficult that probably a solution that you want exists out there, but you still can't use it because it's implemented in a different library or a language that you can't use. And the third thing is the most important problem of all. So even if you have a model, even if you have a working code that you can use, it is almost impossible for you to train that model because to train or to use the model, you need super awesome computing and clusters of GPU. And if you don't have one, it is almost impossible to train or to use a deep learning model. Uh, do you have one such cluster or a supercomputer? I don't have one. So um, unless otherwise you solve all these three challenges that I showed here, it's almost impossible to implement a deep learning model. And don't think you are the only people who think that these are challenges, right? We went to multiple industries and we took a survey of about 113 software engineers. And trust me when I say software engineers, these are people who have tremendous coding experience working in industry, and also they have taken courses in deep learning, formal courses in deep learning, to be able to use deep learning model in industrial problems and solutions. So we took a survey among these software engineers that what do they think about how difficult it is to use deep learning model. Almost 83% of them told that it takes them at least a couple of days to implement one deep learning model. And a couple of days is it's actually a huge time, right, to implement one model. And many of them told that we try implementing a deep learning model for a couple of days, and eventually after that we give up because we are not able to implement it. Um, a lot of people told that they eventually give up and they don't finish implementing the deep learning model. So conceptually, deep learning model might look easy. Algorithmically, it might look easy as well. But when you start implementing a deep learning model and want to use it in a particular application, there are lots of quote unquote engineering challenges in deep learning that inhibits you to use it in real world applications. And this is one of the biggest problems, right? That you have to spend a couple of days. Just think about your course project, right? All you spend is a couple of days in completing your entire course project, and deep learning is a small part of it. And if deep learning alone takes more than a couple of days, when I say couple of days, it's weeks together sometimes. Like when it takes a couple of days, how do you plan to finish your rest of the project? And everybody is bounded by a timeline, right? Everybody has a time-based job, both at work. Even I have to finish my project works in less than a couple of weeks, and spending most of the time in implementing a deep learning model is actually a pain for me. So that's where I asked this simple question, a very simple question, that can we reduce the couple of days to a couple of minutes, and even can I reduce it further to a couple of seconds? That all it takes to implement a deep learning model is just a few seconds. How cool can that be? And I started with this simple question. Okay, this is all I want to do, and that's where I started building this whole research area on how do I democratize deep learning, and the democratization is is as simple as a definition as it can get. That um, deep learning is such a powerful tool that can solve so many problems around us. So every person, irrespective of their skill set, irrespective of their background, irrespective of their experience, they should be able to use deep learning. Deep learning can should be used for every single use case, whether it is medical applications, whether it is aviation applications, whether it is autonomous vehicle application. We should not bother about it. Deep learning should be used for every use case, and deep learning should be usable by every machine. We should not rely that we should have only supercomputers or cluster of GPUs to be able to use deep learning. Let me take an example, right? Most of you are having a phone in your hand probably right now. How difficult it is to use a deep learning model in your phones today. I'm wearing a Fitbit watch here, a smart watch. So many of us are wearing different kinds of wearables today, and these tech wearables have such a small memory, such a small compute, such small capabilities. Can we use those deep learning models into these small devices also? So by definition of democratization, all I'm trying to say is that deep learning should be usable by every person, should be usable by every use case, and should be usable by every machine. And I started with this simple agenda, and most of my research work is based around this thought process that forget about the algorithmic challenges. I mean, don't forget about it, but keep it on the side. That's one set of problems. But the other set of problems that I want to focus on is that even the existing solutions in deep learning is not usable by many people. So how can we make it have a mass appeal that everybody should be able to use it? Right? Yeah. If I have to tell it in a different way, uh, deep learning today is more like a Madhur Bandakar movie. Very few selective audience can go and watch that movie. How can I take that movie and make it a Salubai movie, right? It's for the mass. Everybody can go watch it and enjoy it. Everybody can go use it and enjoy it. That's the idea here. Right? Any questions on this so far? I mean, I've just set up the motivation of why is it challenging to use deep learning and why we should make it so that everybody should be able to use it. How is the part that I'm going to address in the next couple of slides? But if you have any questions till now, I'll be happy to answer them. Chat, raise hands, unmute. Okay, I don't think I'll be able to see the chat for some reason. So if you're writing in something in chat, I'm not able to see it. Mods in the call. Yes, Avidi. Please unmute yourself and go for the question.
Sir, good morning, sir. Sir,
Good
my
morning.
question is actually why that much supercomputer is needed for deep learning, sir? Since I wanted to know.
Correct. That's a good question. The easy answer I'll have some detailed answers in the slides to come, but the easy answer for now is that a deep learning model is a huge model. It takes a couple of gigabytes to store the model and a couple of different GPUs or a cluster of GPUs to train the model. It is computationally very heavy. The number of Do you know how we measure computational complexity of a process? We have something called as flops, like how many arithmetic operations that you do, floating point operations. Flops means floating point operations. In simple terms, how many addition, subtraction, multiplication, and division operations that you're doing. And the number of addition, subtraction, multiplication, and division operation that we'll have to do inside a deep learning model is pretty huge. And that kind of heavy computation we cannot do it inside a single mobile phone. We need huge RAM capacity and huge buffer capacity and memory capacity to be able to train the models. And why we need that, I will use some of the slides in the future to answer that question.
Thank you, sir.
Amrit, you had a question as well. Has the been a step in democratizing step towards? Hi, Amrit, you had a question.
Hello, am I audible?
Yes, you're audible now.
Okay. Wait. Ma'am, I'm facing some issue.
No worries, but I'm able to hear you.
Hello.
Yes, hi.
Yeah, my question was that has like the usage of GPU instead of CPU, has it
Mhm.
been a step towards democratization?
Uh, Actually, no, in the sense that so many people, so many of us, like think about even us, right? So many of us still very recently had only CPU based machines that we were using, and suddenly they told that to be able to train or run or use deep learning models, you need GPU based machines. So what that means is that we'll have to get rid of all the CPU based machines that we have today and replace them with GPU based machines. And how many of us can afford to do that? All the desktops that had CPU, all those servers that had only CPUs cannot be used for using deep learning model. Think about huge companies, right? They'll be having thousands of machines that has only CPUs. Um, so that is challenge number one, that we'll have to replace the existing infrastructure of CPU based machines with GPU based machines. That's challenge one. And challenge two is that even if you want to replace them with GPU based machines, they it is simply required that you need 512 of those machines, 1024 of those machines, 2000s of those machines to be able to train a single deep learning model. It is not sufficient if you have a single GPU machine. You need thousands of GPU machine to be able to train a deep learning model. So it is surely not a path towards democratization.
Okay, yeah, that answers me.
Awesome. Was there a different hand? Uh, okay, I'm not able to see a different hand, but if there was a different hand, please unmute yourself and please ask the question.
Hello, sir.
Hi.
Sir, I want to ask that means I don't understand the model part, model diagram. Means
Correct.
what is mean by model, and what, there are many blocks of different color. So what they
Yes.
represent?
Okay. I intentionally made that part of the talk as out of scope of this, because to explain what the different color means itself is a totally different subject. It will take more than a couple of hours. The idea is that okay, there are two things. The first idea is that you need not even know what each of the color boxes means. You should still be able to implement it and use it. That's the first answer. And the second answer is that if you still want to know what each of the color boxes means, in simple terms, each of them is a mathematical function. Uh, we know lots of mathematical function, right? There is a logarithmic function, exponential function, sine function, cosine function, tangent function, power function. We know a lot of mathematical function. Each color box is basically one such mathematical function that we are trying to do. So when we get an input of data, we try to apply a series of different mathematical functions on this data to be able to do a particular task. Now, what those mathematical functions are something that is out of scope of this particular talk. There was one
Yes,
more question. Sorry. Please, there was one more question. Please go ahead and unmute
Yes,
yourself.
hello, sir.
Hi, Arta.
Sir, my question is, can can we use analog computers for the uh, computational part?
Unfortunately, no. Uh, I mean, I don't know an easy way to answer that question except for saying no. Um, for now, you'll have to trust me with the answer that it is not possible to use analog computation.
Okay, sir.
Okay, so with that said, let's go ahead and see how we have made the world a little bit better by democratizing deep learning, right? Let's start with a simple example. Here is an example research paper that tells you how to design a deep learning model for doing face recognition. And the, the the lots of color boxes that I showed is equivalent to the diagram that you can see on the left part of this figure, right? A lot of boxes that processes the input face image and tries to identify which person this belongs to. uh, typically you need to implement thousands or 2000s of lines of code to be able to implement this particular diagram that is shown here. Okay, but what we are proposing is, or what we have designed is, hey, there is no need to code deep learning at all. Let's take coding out of the picture and let's design a no coding platform to be able to implement deep learning model. And here is an example video where I'm showing that how we can implement the same paper without writing a single line of code. And all you need to do is just look at the figure that is on the right top of this image. And once you have this figure, just whatever be the color box that you want, all the color boxes are available already in this UI system. You just have to drag and drop these color boxes, join them together, copy paste the. If you want, you can double click, set some parameters on it, some options that you want to set. So the idea is that you need not know coding at all. You need not know what this diagram means at all. All you need to do is that, hey, the first box in this diagram means an orange box. The second box means an yellow box. And that you can do by simple name matching. The box will have a name on top of it. And these color boxes will also have a name. So you can just copy paste. It will help you debug also, saying that, hey, the diagram that you drew has some mistakes in it. Why don't you fix those mistakes? And once you do all those things, you can just download the code and look at here. The entire code of what you should have implemented can be completely downloadable. So you can just visually drag and drop a whole deep learning network without knowing what it is, without knowing how to program. And you can just download the code in any language of your choice, in any library of your choice. And we developed this no code platform as a first step towards uh, the democratization of deep learning. But some of you might find this cool, and some of you might find this boring, saying that, hey, I don't even know what these boxes means. How do you expect me to drag and drop the correct boxes, join them together, download the code, and all those things? We said, okay, let's solve that problem also. That why do you need to drag and drop when you can just sit and eat popcorn, right? And have a good time and let the computer do all the work for you, right? So that is where we thought, hey, here is a paper, a research paper that I just showed now, that explains what a deep learning model is. It has a figure that explains the architecture. It has a lot of textual information that explains what we need to do. So why don't we just automate this whole task? Just give this paper to the system. The system will understand what this paper is, what are the intricacies of this paper, what architecture is being explained in this paper, and it will implement things for you automatically. You need not even drag and drop. And that is where we came up with this solution called DL paper to code. Just upload the PDF of a research paper. It will understand the entire contents of the research paper. It will implement the code for you and provide you with the code. And that is what we're doing here. Let me fast forward it to the place where it is more interesting. How about here? Yes. All you're trying to do now here is just upload the PDF of the paper. Let the system do all the work for you. And that's it. As simple as that. Like just upload the PDF. You see a paper. Hey, here is a paper that does autonomous vehicle, right? Here is a paper that does brain tumor detection. Just download the PDF of the paper. Just upload it in our system. The system will completely understand, okay, this paper is about brain tumor segmentation. They have implemented so and so deep learning model. This is what we need to implement. It will understand the text part of the whole paper. It will understand all the images part of the whole paper. It will implement the whole deep learning model in code for you and provide you with the code. All you need to do is upload the paper and download the code, and that's it. And it takes just a few seconds to be able to implement the whole paper, right? How easy can it get more than that? And that is what I was stressing sort of from the initial point that we are trying to black box the whole setup of deep learning implementation, that you need not even know what this implementation is or what deep learning is, but without even knowing it, you should be able to use it. And for people who know what deep learning is, it is even much faster or easier for them to use it in the sense that they can use it for very quick experimentation, right? Instead of taking days together or weeks together to implement a deep learning model, it just takes them a couple of seconds to implement a deep learning model now. Yeah, that is what we are doing. And as a information fact for you, all of this is now a part of IBM Watson. I was initially working with IBM Research, and we call it neural network modeler. You should be able to model any kind of neural networks and for any application and use case. So in the democratization part, the first two motives that I told, right? Any person should be able to use it, and you should be able to use it for any use case. And we have solved both these parts of democratization of deep learning. I should not say solve. We have made some good progress in solving these two parts using neural network modeler. Here is a small movie for you.
Hello, today we are going to architect a neural network with the Neural Network Modeler on Watson Studio. After logging in, click New Modeler Flow. From the New Modeler Flow page, you can create two different kinds of flows. One is the traditional.
And I'm just going to highlight the important parts of this video just for the time of it. And all these videos are available in YouTube. And so many documentation and demos, right? So feel free to look at it after the presentation.
Seems good. Of course, you can create a new network from scratch, but we also offer a variety of a convolutional neural network operations, which define a computational graph, along with information about the location of our training, testing, and validation data. Here, we first use the image data node to define a graph, beginning with the.
So here is an example, right? That here is a deep learning model that we can easily drag and drop and design also. Say, for example, I as an expert have designed this deep learning model, right? And share it with the entire world and said that here is a deep learning model that can detect faces in an image when you give it. And you as a person who's new to deep learning model can just download this architecture from neural network modeler in IBM Watson. And the best part is you can even play around with this model. You can make some modifications to this model. You can make some edits to this model. And it's as simple as.
Now, we perform validation on your design, and the settings dropdown provides us the tool, but we'll change this to 0 and move on. Let's open our 2D convolutional layer and take a look at some of the parameters. The neural network modeler will try, but the configuration pattern is the same. Specifying the optimizer is usually look okay and get ready to network modeler. You can download.
And this was the part that I was highlighting, that once you're completed with the design of the neural network modeler, you can just press download. And I showed you different libraries upfront, right? You can use Caffe as a library to implement it. You can use TensorFlow or Keras as a library, or you can use PyTorch as a library to implement deep learning models. And these are fundamentally different libraries, different syntaxes, and different languages. And you can just design a whole model and just download the code in any library or language of your choice. You can even download the code in all libraries and languages. Give me the same model in Caffe, same model in Torch, same model in TensorFlow Keras, and it is as simple as that. Say, for example, I'll give you a funny incident that happened with one of the universities that we were working in. The student was using this system to implement one of their course projects. They implemented, downloaded the whole code in PyTorch, and went ahead and submitted the assignment, which is a fair way of submitting the assignment. The teacher was aware that the student was using this tool to implement or finish their assignment. But then everybody had in the class had used TensorFlow Keras to do their assignment. But this student or this group of students alone had used PyTorch to finish the assignment. And somehow the professor of that particular course told that, hey, I want everybody to uniformly use TensorFlow Keras. You have used PyTorch, which is correct in its answer, but I want you to re-implement the whole stuff in TensorFlow Keras. Now, if this feature was not there, the student would have took it would have taken the students a couple of another set of weeks or sometime even months to re-implement the whole stuff in TensorFlow Keras and give it or submit it back to the professor, right? But using this tool, all they had to do is they just told the professor, just give me 1 minute. They on logged into the system. They had the design already stored and saved. They just downloaded the whole code in TensorFlow Keras and mailed the professor. All it took them is just 1 minute to resubmit the assignment in a different language or library, right? And that is the kind of easiness of use that we are trying to achieve using these systems. Um, okay, so this sort of gives an overall idea. I know I'm just giving a very high level idea, and that was the intention of this whole talk, not to go into details of it, but just get you excited about what we can do in using these stuff, right? And this set of this neural network modeler solves the first two problems that we were dealing with. One is how we can how any person or any student with no background or limited technical background should be able to use deep learning, and we can use it for every single use case. It doesn't matter what use case that you're using it for. Now comes to the last set of problem, that is how we can make every machine use deep learning model. I want my smart wearables, I want my mobile phone to be able to use deep learning model, and I don't want to rely on just large supercomputing capabilities, right? So first of all, why do we need supercomputing capabilities, right? Let us look at some of the current deep learning models. Don't even worry about what is inside them, but the facts that I'm trying to explain here is NVIDIA came up with a deep learning model called Megatron, and it has 8.3 billion parameters. And we need 512 GPU cluster to be able to train this model, right? This model, which is a language understanding model, this model can understand any language that is thrown at you, right? English, French, German, whatever is the language that you throw at it, it will be able to understand these languages. Microsoft came up with a Turing model, said that, hey, NVIDIA, you used only 8.3 billion parameters. Let me just double the size of that model, right? And come up with a 17 billion parameter model and called it a Turing model. Then came OpenAI and said that Microsoft, you're using only 117 billion parameters. Let me make it 10 times bigger, right? And create a 175 billion parameter model. They call it GPT-3. It's one of the state-of-art models that we see here. Now, here comes the question that I want to answer, right? This model, just to store this model in disk, you need 350 GB in size. That means that you need an external hard disk or a hard disk that has 350 GB memory to be able to just store this model, like model.save, and store it as a file. To be able to store it as a file, you need 350 GB of memory. How many of your phones have 350 GB in memory? Like the best I can see is 128 GB or 256 GB in the best place, right? And even if I have a 512 GB memory in my phone, 350 GB of it will just go in one model. Think about the other OS softwares, other files, applications, pictures, movies that I want to store in my phone, right? That is for a phone. And in the worst case, if it is a 128 GB phone, you can't even think about storing this model inside your phone. And think about this small, tiny smartwatch that I have. Okay, it has 512 MB in memory at the best. What I can do with 512 MB in memory if the model is 350 GB in size, right? And the bigger pain point that I want to highlight is, see, even if I have a 350 GB memory and a supercomputer, the cost that is required to train this model is 12 million US dollars. How many of us can afford 12 million US dollars to train this model? Yes, Avidi, please go for it. I think you need to unmute yourself because I'm not able to hear you, Avidi.
Sorry, okay. Sir, can't we compress these files, sir?
That is what I'm trying to say now. That is what we are trying to do as a part of democratization. As we know, in any kind of compression, Avidi, compression means most of the compression techniques are lossy compressions. The moment we compress these models, the accuracy performance of these models decrease a lot. That, say, for example, I have a 95% accurate model that is 350 GB in size. But the moment I start compressing these models, the more and more and more I compress, the more and more the accuracy will drop, which will come from 95% to 70% to 60% to 50%. So it is very, very, very challenging to be able to compress these models without dropping the accuracy of uh, these models. And that is a bigger pain point, and that is what we are trying to solve as a part of democratization of deep learning. I mean, it is what we are trying to do right now. Right. One more question that I want to answer is, one obvious question that you can think is, why do I even need to put these models into my edge devices? We call these edge devices, right? The cloud computers are what is in the cloud, and what we have in our hands, any small devices like laptops, like phones, like tablets, like smartwatches, everything, like even small chips and sensors, all these are called as edge devices. And why is the need for even putting these models in edge devices? Why can't these models be in the cloud devices forever? The reason is the amount of edge devices that we are manufacturing and we are creating are exponentially increasing every year. Like um, this year alone, there is 40,000 million of edge devices that are there in the market. How many edge devices are there? 40,000 million edge devices that are there in the market. And we really need to use these deep learning capabilities on these edge devices to be able to uh, make full use of these, right? Just take my smartwatch an example, right? You start running any day just for fitness or just for jogging. The smartwatch automatically identifies that you are running, that whatever motion that you're doing is running. And how does the smartwatch detect it? It internally uses some kind of a deep learning model to be able to detect that you're running or not. But how is the detection happening? Uh, the smartwatch is basically collecting some data when you're running, like your heart rate, your blood pressure, whatever is the data, right? Some different kinds of data from your smartwatch. It goes in via Bluetooth to your phone. From your phone, the data is transmitted to some server, and in that server, a deep learning model is running. It is identifying whether you're running or walking, you're jogging, you're exercising, whatever it is. That information is sent back to your phone, and that information is sent back to your smartwatch. And your smartwatch is saying, "Hey, I found out that you're running." But just look at the amount of computation that happens before the smartwatch is detecting that it's running. Instead, if we have the deep learning model inside your smartwatch itself, there is no need to send the data every single time to your phone and to the cloud and back from the cloud to your phone to the smartwatch. Everything can happen inside your smartwatch itself, right? And any kind of typical edge computing has a memory footprint of just 1 MB, right? It's not GBs, it's just 1 MB is the average chip size. Its power consumption is less than 10 watts, and its computational complexity is also like 10 teraflops, right? Not more than that, which is very, very, very less. And the cost is like $10. You can buy a simple chip for $10 anywhere outside. You need not spend $12 million to buy a supercomputer to train a model. So this is why we need edge computing, and this is why we need to start using this edge computing to be able to use deep learning model. But how do we use it? But before even going there, you can again ask me the question that I don't care if I want to send my data every time from my smartwatch to phone to cloud and then back from cloud to smartwatch. I don't care if that happens. I'm okay with it, right? Let's do it in this way itself. And I don't want to even put my deep learning model into my watch. If you're trying to ask that question, here is a simple video of why it is really, really important. Okay. Let's take an example of a self-driving car or an autonomous car, right?
How reliable is artificial intelligence? It's a question that has come up a lot lately, especially with the rise of self-driving cars. Reaction time is a critical factor. Although the AI-enabled detection is good, it's not perfect.
This is the whole reason why we need the deep learning models into the system itself and not in some cloud. Just assume this scenario: a self-driving car is coming real fast, and a person suddenly walks in front of it. If the deep learning model was on the cloud, what will actually happen is that the self-driving car will have a camera in front of it. The camera will capture pictures of whatever in front of it, take those pictures, send it to your phone, and via your phone, it will be sent to the cloud system somewhere in the world where we don't know where the cloud system is. The cloud system will process this image and tell, hey, there's a person in front of you. You need to apply brake. And then that information is sent back to your phone from the cloud and from phone to your vehicle. And then the vehicle applies a brake. By the time this whole process is finished, you can run over the person a couple of different times, right? The reaction time is really, really critical in many applications. And just to make the reaction time really fast, we cannot rely on any kind of a network that is happening. We know how much latency networks can provide, right? Upload the data, download the data can really provide bad latency, and an accident would have happened in this case. And that is why it is very important that this deep learning model is inside the car itself in a small computer, in a little tiny computer. The deep learning model is inside the car itself. The pictures are taken by the car. The deep learning model inside the car itself, there is no network, there's no upload download. The deep learning model inside the car itself decides whether you need to stop the car, turn left, turn right, or you need to accelerate. Whatever is the decision, it is taken inside the car itself, and the car itself takes a decision, right? So the reaction time is very fast, and we can be more trustworthy of the kind of systems. But what is the challenge in this case? The deep learning models are really large, so we cannot fit it inside a tiny computer inside the car itself. The car can hold only a small, tiny computer. It cannot have a mega super size computer inside it, right? That's the first challenge. And the second challenge is that the bigger the model size, the more power it consumes. And the more the power it consumes, the battery power of the car is drained. Most of the self-driving cars, if it is an e-battery driven vehicle, the charge that we have in the vehicle supports only 6 hours or 8 hours as of today, right? At the worst case, 12 hours. And if the deep learning model inside this computer starts consuming most of the power, right, the whole battery power of the car will be reduced to 2 to 3 hours. That means that you cannot travel at a stretch anywhere beyond 3 hours without recharging the vehicle. And that becomes super complicated. We don't want to do that also. And that is where we are trying to optimize a deep learning model. And what are the different optimizations that we're trying to do? Here is a deep learning model. We need to optimize the deep learning model, make it smaller, faster, whatever it is. Most often, when we think about optimizing deep learning model today, many people think about optimizing the accuracy alone, right? Let me make it, today the model is 90% accurate. Let me optimize it to make it 92% accurate, to make it 95% accurate, to make it 98% accurate. Many people think accuracy as the only metric to optimize or to learn a deep learning model. But what we are highlighting is that we should look at multiple other metrics. The number of parameters in the model, the lower the number of parameters, the better it is. The number of flops it takes, the size of the model, the time it takes to train the model, the time it takes to infer using the model, and most importantly, power consumption of the model. So we should not only optimize the accuracy of the model, but all these different parameters has to be optimized together. And that becomes a complex learning problem. And when I was working with Deep Light, we developed a product and a system called as Neutrino, which does exactly this thing. Just assume, just as a use case here, I have a deep learning model that has 549 MB in size, right? Deep Light has a system. All you need to do is upload this model to Deep Light system and tell to Deep Light system, hey, compress this model for me, right? And you use a deep search and compress this model. But along with it, you can also specify that while compressing this model, all I'm willing to sacrifice or trade off is only 0.5% of accuracy of my model. Say, for example, if my model was 95% accurate, that means that the compressed model should not go below 94.5% accuracy. That is all I'm willing to trade off, 0.5% to be able to compress the model. And what DeepLight's neutrino system will do is will automatically understand the whole model for you. You need not worry about what this model is about, right? Or how to compress this model. The DeepLight's neutrino will do it automatically for you and provide you with a compressed model, which is like only 11 MB in size with almost 50 times compression, 4x speed up, 5 times lesser power consumption, and accuracy change of only 0.3%, right? 95% to 94.7%. That's all. But it is 50 times smaller and 4 times faster, and 5 times power consumption reduced as well. And that is what we are trying to do using uh, in as a part of democratization of deep learning, uh, by making deep learning model available to every device that is possible. I will show you a very concrete example that we were working with a um, company, a third party company, um, wherein they wanted to build a home assistant system that wakes up as soon as it detects a person. When you walk into a room and as soon as you detect a person, this home assistant should be able to wake up. So they used a small $40 chip which consumes only 3 watts of power, the smallest chip, to detect if a person is there or not. But in order to accurately detect if a person is walking in or not, they need a huge deep learning model, and the model is almost 12 MB in size. Whereas this particular chip had only 512 KB in size, right? Which is a RISC-V CPU core. So that is what they told. Hey, my original model is 12 MB in size, but my requirement is that the model size has to be less than 256 KB, and I'm willing to let go of 2% of accuracy drop. This is all is given. We don't even need to know what that MobileNet V1.0 model is. That is not required by Andes technology. They gave it to DeepLight's Neutrino, and this is what DeepLight's Neutrino produced: a 188 KB model, which is 69 times much smaller, but with an accuracy drop of less than 1%. So they were able to take this compressed deep learning model and put it inside their chip and deploy this chip also. And yeah, that is what we are trying to achieve by democratizing deep learning model, so that every system or every chip or every device in this world can use deep learning model, right? Yeah, and just for your happiness, this Neutrino is actually a free to use software. It is available in GitHub. Most of the source code is also available. So you can go ahead today, use these Neutrino compression library to compress any deep learning model, right? And to give you a full picture, as of today, you guys, girls can use deep learning model. You need not even know what a deep learning model is. Just go to IBM neural network library or modeler. Just start dragging and dropping different layers together. Decide any deep learning model of your choice. Download the deep learning model, but the deep learning model will be really large for you to train it using your laptop. So then you can take the deep learning model from neural network modeler, give it to Neutrino. Neutrino will compress it model, make it really, really tiny and small for you. And you can use that small, tiny deep learning model inside your laptop itself. And most cases, you can use it inside your phone also. And that is what we are trying to achieve by democratization of deep learning for every person, for every use case, and for every machine. On that note, a huge shout out to all my fantastic collaborators over the many years that I have worked across different organizations, companies, and projects to be able to make progress in this vision and dream that I'm having, right? That everybody in this world should be able to use deep learning model. Thank you. I know I have a couple of, I know I just have 1 minute left, but I can spend a couple of more minutes if you have any questions. Or if you have any questions that you would like to write to me, you can write it to me in my email. All my social media handles are at Goodboy Anush, so you can reach out to me in any social media of your choice.
Thank you, sir, for the wonderful session. We have it out, and I would like to present it. What would you recommend for a beginner to stay motivated to conquer the learning curve? Like to go through the years it takes to learn to implement these models.
It is very tough. You just need internal passion to be able to solve something big. And just to motivate you, I gave you the first few examples, right? Most of the revolution is happening today in multiple industries is because of deep learning. So if you think in the next couple of years you want to create a revolution of your own, then you need to go through the grind a little bit. to be able to learn deep learning from its fundamentals to the advanced stage. But in that whole process, what I'm hoping is that some of these tools could help come in handy to ease that whole process of learning process, right? A learning curve. And that's the whole aim of it. No way that these tools are going to replace the whole learning curve, but it might help you to ease it down a little bit.
Okay, thank you.
Any more questions? Wonderful. If there are not any more questions, I wish you. Okay, there was a raise of hand. Please go for it.
Sir, in the process of simplification, could we replace deep learning with simpler models?
That's a really, really good question. Thank you, Amrit, for bringing that question. Unfortunately, no, because it is well proven in literature, multiple people doing multiple experimentation across multiple problems, where they say that deep learning is much, much more powerful than simpler models. And using deep learning can provide you much higher accuracy, right? But by gaining much higher accuracy, deep learning has introduced a lot of other parallel problems in terms of time, memory, computation, etc. And that is where we are trying to get the best of both the worlds, right? We still want to use a deep learning model to get best accuracy, but can we use its power consumption, memory consumption, and time consumption so that we can get the results in a much faster way?
Okay, sir.
So Garima has asked a question in the chat. She's asking, how do we take care of AI ethics while training such models? For example, while collecting the datasets, privacy is often compromised. How do we account for that?
Yes, that's a whole world of questions there. Thanks again for bringing that question. Yeah, there are lots of. Unfortunately, as it may sound, there is no technical way of solving the problem. People are trying to solve this problem technically, but technology is not the solution to solve the problem of AI ethics. We should basically have rules and regulations. Right? When you're collecting data, follow these rules, follow these regulations. We should have a law, and all of us have to obey by that law. And that's the in my opinion, that's the correct way to solve the problem of AI ethics. And technology can help you achieve that, but we need something more fundamental than technology to solve that problem.
So, can I have a question?
Please go for it.
Yes, sir. Like NVIDIA Jetson series is related to AI hardware. So, in schools, especially in the States, it is
Mhm.
used in high schools to teach children some basic AI. And I
Correct.
think this is a big step towards democratization. Do you think this should be expanded to other countries, especially India, where
I
it has a
have
lot of
I have
potential?
been a big proponent of that thought that in schools we should do some hackathons, make people play around with these kinds of machine learning, deep learning models, make people aware of different kinds of hardwares. Any kind of an NVIDIA series is good, right? Um, it is good to start with, and we should bring that into our school curriculum. As a matter of fact, when I was working with IBM research, I have gone to multiple schools myself. I've conducted workshops so that students are aware of these things at school level itself. Um, yeah, I'm a strong believer of that.
Thank you, sir, for your view.
Yes, please unmute yourself and go for it. There was a question, I believe. And if you are very hesitant to ask questions during this presentation, feel free to write to me or drop me a DM in anywhere of your choice. And if there are no more questions, I wish you all a wonderful weekend. I hope I got you excited with little things about deep learning. Um, have a great afternoon. Thank you so much for this opportunity.
Once
Thank
again, thank you very much, sir, for such an informative session. We all definitely learned a lot from this.
Wonderful. Glad that you felt that way, part.
Thank you, sir. We would also like to thank the audience for paying attention throughout. Thank you, everyone.
Thank you. Bye bye.